Hi everyone, welcome back to my channel Computer Classes by Rachna. So today we will talk about implementation of XOR gate using the Perceptron rule. Those who do not know what is Perceptron rule and implementation of OR gate, implementation of AND gate, I have put the video already. So please see that video and then come back here. So now we have to implement the Perceptron rule for XOR gate. These are the inputs and outputs shown for the XOR gate. We have x1 and x2 as input and y is the output. So the values that we have taken for x2 are 0, 1, 0, 1 and for x1 are 0, 0, 1, 1. We will consider one training sample at a time. So these are 4 training samples which are 1, 2, 3 and 4, and we are having different set of values of inputs and we have some expected output which is y. So how does XOR work? The actual function of XOR is if x1 and x2 are the inputs, so XOR output of x1 and x2 would be y. Y is calculated as x1 into x2 whole bar plus x1 bar into x2. This is how it is performed. So when we find x1 into x2 bar plus x1 bar into x2, we get the value of y, where bar means the complement. Complement means when x1 is 0, x1 bar will be 1. When x1 is 1, x1 bar will be 0. So the value will reverse. Now let's see the inputs and how XOR actually works. In XOR, when the x1 and x2 value are same, we will get a 0. And you can see these two cases where x1 and x2 are 0, the output is 0. When x1 and x2 are 1, the output is 0. So when the inputs are same, the output is 0. And when the inputs are different, you can see these two cases where x1 is 0, x2 is 1, and x1 is 1, x2 is 0. When the inputs are different, then the output is 1. So we have to implement Perceptron rule for these. What is Perceptron rule? We say that every input has a weight. So Perceptron rule is we calculate xi, wi for all the inputs and their corresponding weights. Then we add them. So we get the sigma xi, wi for all the inputs and their corresponding weight. And then we find out whether we get the expected output and the actual output as same or not. If the output is not same, then we have to change the values of these weights and we have to work on these values on the basis of a particular function. So let's see first of all what we get as the value of sigma xi, wi. But for that, we have to resolve this complicated equation. So let's say that this portion is called as Z1 and this portion is called as Z2. So Z1 becomes x1 into x2 bar and Z2 becomes x1 bar into x2. So we can say y equal to Z1 or Z2. OR means the function, logical OR. Now let's see this diagram. So we have x1 and x2 bar, which is Z1. So for x1, this is the input and this is the weight associated with x1, which is called as W11. For x2, this is the input and this is the weight associated with x2 bar, which is W21. So W11 means weight of Z1, weight 1 of Z1, and W21 means weight 2 of Z1. So this is the weight 1 of first input, which is x1, and this is weight 1 of second input, which is x2 bar. Alright, so this will be z1. So z1 is what? x1 into x2 bar. And what is z2? z2 is x1 bar into x2. So now what are the weights associated with x1 bar? So this is the weight associated with x1 bar, and this is the weight associated with x2. So it is actually weight 2 of x2, and this is weight 2 of x1. Alright, second weight for z2. So this is weight 2 for the value x1 in z2, and this is the weight 2 for z2, which is for the value of x2. So the naming is on the basis of z1 and z2. Okay, so this is first weight for z1, and this is the second weight for z1. Okay, and this one is the first weight for z2, and this is the second weight for z2. Okay, so now what we will do is we will find out how to solve this diagram. So we have to assume W11 and W12 for Z1, and we have to assume W21 and W22 for Z2. This is what we are going to do. So look at this function. We are assuming W11 and W21, which means the first weight of Z1 and then the second weight of Z1 to be 1. We are assuming that both are 1. Then we have to assume the threshold value. We will take the threshold value to be 1, and we take the learning rate as 1.5 initially. So this is a random guess that we have done, and we have taken these values as assumptions. Now we calculate Z1 equal to x1 into x2 bar, and we find out the training samples. These 4 training samples are there for each of the rows. Can you see that? So these are the 4 training samples: x1, x2 and z1. Z1 is the first output. Alright, so here what we have done, z1 is nothing but x1 into x2 bar. So we have calculated it. So x1 is 0 for the first example. X1 is 0 and x2 is 0. So 0 bar means 1. So 0 into 1 is 0. Now in the second example, x1 is 0. 0 multiplied by anything would be 0. So the output is 0. In the third example, x1 is 1. x2 bar means, these are the values that I'm writing here for you to understand for x2 bar. So this is x2 bar, this is x2 bar, this is x2 bar, this is x2 bar. So x1 into x2 bar we have to find out. So x1 into x2 bar is 0 here, x1 into x2 bar is 0 here, x1 into x2 bar is 1, and in the fourth case x1 into x2 bar is again 0. So the only case where we will get the output as 1 would be the third training sample. Am I clear? So now what we have to do is we find out the value of y. Y is the output, which is z1 here. So the threshold value for the function would be 1 if the y in, which means the output that we get, is greater than equal to 0, and it will be 0 if it is less than 0, which means if our answer comes out to be negative, we will take it 0, and if the answer comes out to be positive, we will take it 1. This is the function behind it. So now we just see what we get here. Alright, we will now apply the weights for the first case, alright, which is z1. So we calculate wij into xi. So what is wij into xi? So we are doing it for, firstly we are doing it for x1 and then we will do it for x2. So for x1 equal to 0 and x2 equal to 0, what will be the value when we multiply the weights? What are the weights? 1 only. So 1 into 0 and 1 into 0, we will get 1 as the output, and this was the target output. So it means that our actual output is equal to target output. Now we take the second case. The second case is 0 and 1. So again 0 into 1 plus 1 into 1. So 0 into 1 plus 1 into 1, we will get 1. Now the actual output is 0, but what we are getting is 1. So the actual output and the target output are not same. Since they are not same, we have to adjust the weights, and we can adjust the weight with this formula: wij equal to wij plus n into t minus 0 into xi, where wij are the corresponding weights, and then this is for the new calculation, new weight to be calculated. This is the old weight, which could be w11 and w12, and this is the value of n, which is the learning rate that we have taken to be 1.5. This is the target output, and this is the actual output, and this is the input. So when input is x1, we will take w11. When the input is x2, we will take w12. So let's see how we calculate the weight. So now that we know, we got problem in the case where the actual output and the target output did not match. So since the actual output and the target output did not match, we need to update the weights. The target output was 0 and the actual output came as 1 for the second training sample. So what we have to do, we have to calculate the weight. To calculate the weight, we need to apply this formula: wij equal to wij plus delta w, which is equal to wij, which is for the new weight, which is equal to the new weight equal to the old weight, plus n, which is the learning rate, t, which is the target output, minus o, which is the actual output, into xi, multiplied by the input xi. So now we calculate w11 first, then we will calculate w21. W11 is the weight which is first weight for Z1, and W21 is the weight which is the second weight for Z1. So W11, the new W11 is equal to the old W11, which was 1, plus the learning rate, which is 1.5, then the target value, which was 0, minus 1, which is the actual output, and multiplied by x1, which is 0. Now why x1 is 0? To show you why x1 is 0, we have to take x1 as 0 because this is for the second training example, and in the second training example the value of x1 is 0. Since we are having problem in this output, so this is the value of x1 and this is the value of x2. Okay, so now moving back to what we were doing, we got this 1 plus 1.5 multiplied by 0 minus 1 multiplied by 0. Now anything multiplied by 0 is 0. So 1 plus 0, which is equal to 1. So the new weight also comes out to be 1. The old weight was also 1 and new weight is also 1. Now we calculate the second weight. So the second weight W21 is equal to the old value of W21 plus n, which is the learning rate, into target value, which was 0, minus o, which is the actual output, multiplied by the second input, which was x2. So 1 plus 1.5 into 0 minus 1 into 1. So 0 minus 1 is minus 1. Minus 1 into 1 is again minus 1. And minus 1 into 1.5 becomes minus 1.5. So this 1.5 into minus 1 into 1 would be equivalent to minus 1.5. So here we have 1 minus all this. So 1 minus minus 1 plus all this, so this becomes 1 minus 1.5. So 1 minus 1.5 is equal to minus 0.5. This is equal to minus 0.5. So the new weight comes out to be minus 0.5, and the new weight for the previous one is same as the old weight, which is 1. So W21 becomes 1 and W11 becomes 1 and W21 becomes minus 0.5, and then we are holding to the older values of threshold and the learning rate. Alright, now what we have to do with these new weights, we have to apply sigma Wij, Xij, Wij into Xi again to all the training examples, which are these 1, 2, 3 and 4. So we will apply the same values, and so what is x1? x1 is equal to this, and x2 is equal to this for the first case. So we will apply the values again with the new weight, and what we will get, the new weight value I'm writing here, see, W11, and this is W12, yeah, W21, second weight. W11 came out to be 1, and this came out to be minus 0.5. So I'm repeating this value here, same value, same value. So when 0 multiplied by anything, the answer is 0, plus 0 into anything is 0. So here we get sigma xi is 0. In the second case, 0 multiplied by 1 is 0, plus 1 multiplied by minus 0.5, so we get the output as minus 0.5. Then we have 1 into 1 is 1, plus 0 into anything is 0, so we got 1. And now 1 into 1 is 1, plus 1 into minus 0.5, so 1 minus 0.5 will become 0.5. So these are the answers. These are the answers that we get for output. And if you remember, our function is, if it is greater than equal to theta is the threshold value. So if it is greater than equal to theta, we get the output as 1. If it is less than theta, we have the output as 0. What is the value of theta, the threshold? 1. The value of theta is 1. So if it is less than 1, the output is 0. Is it less than 1? Yes, so the output is 0. Is it less than 1? Yes, so the output is 0. Is it less than 1? No. Since it is equal to 1, the output is 1. Is it less than 1? Yes, so the output is 0. So we get this answer, the final answer, as 0, 0, 1, 0, because it should be the same values as the comparison that we made to theta. If it is greater than theta or equal to theta, the output will be 1. If it is less than theta, the output will be 0. What is theta? The theta value is 1. Clear? So now look at the right hand side of this. These are the values 0, 0, 1, 0, and look at the Z1 0, 0, 1, 0, which means these are the new weights which are correct for all the training examples. So these are acceptable weights. What are the acceptable weights? W11 as 1 and W21 as minus 0.5. All right. Now this same calculation is shown here. This same calculation is shown here, that we calculated Wij into Xi and we got these values 0, 0, 1 and 0, which is same as the target output and the actual output. So since target output is equal to actual output, no update required, and the weights W11 as 1 and W21 as minus 0.5 are finally acceptable for X1 and X2. Alright, for Z1. X1 and X2 of Z1. Clear? Now we apply the perceptron training rule for Z2. Now what is Z2? Z2 is X1 bar into X2. So what should be the value of X1 bar? I can write down here X1 bar. So if X1 is 0, X1 bar will be 1. This will be 1. This will be opposite 0. This will be opposite 0. So this is the value of X1 bar. We have to calculate X1 bar into X2. So this is X1 bar into X2. What will be this? C. Z2. So 1 into 1 into 0 is equal to 0. 1 into 1 is equal to 1. 0 into 0 is equal to 0. 0 into 1 is equal to 0. So that is how you get this output of Z2. I hope it is clear to all of you. Now we have the output of Z2. We have to apply the perceptron rule. So again what we have to do? We have to apply X1 into W12 and X2 into W22 and we have to add that. So this is what we are going to do for all these training samples, and the weights that we are assuming are same, 1. So we are doing 0 into 1 plus 0 into 1. Anything multiplied by 0 is 0, so answer is 0. So this was the actual output and this is the expected output, and we get the same as the actual output also. C for the first case. This is the first case. So we have sigma wij xi equal to 1 into 0 plus 1 into 0, and it comes out to be 0. Then you have the second case, which is this x1 1, x1 0, x2 1, and the actual output is to be calculated and compared to this target output, which is 1. So we find out x1 is 0, x2 is 1, and we multiply 1, which is the weight, wi into xi plus wi into xi. So 1 into 0 plus 1 into 1. This comes out to be 1. Now this is the actual output and the target output becoming same, so no update. Since in both the cases the actual and target output are same, so no update required. Now we move to the third case. This is the third case where we have x1 equal to 1, x2 equal to 0, and the output which is expected is also 0. So we have 1 into 1 plus 1 into 0, but the output that we are getting is 1, and the output which is the target output is 0. So this is not same. Target value is 0, so target is not equal to actual output. Since the target value is not equal to actual output, again we need to adjust the weight. What is the formula for weight? Wij equal to Wij plus delta W, which is change on weight. How to calculate this change in weight? The old weight is here plus change in weight can be calculated by learning rate into target minus actual into the input xi. So what is the old weight? 1 plus the learning rate 1.5. The target value 0, actual value 1, and multiplied by 1. So this comes out to be 1 minus 1 plus minus 0.5, which comes out to be minus 0.5. Now W22 is 1 plus 1.5 into this into 0. Anything multiplied by 0 is 0. So 1 plus anything is 1 plus 0 is 1. So this is what we get as the output for W22. So the new value of W12 is minus 0.5, but the new value of W22 remains same, which is 1. So now we apply these weights, W12 minus 0.5 and W22 as 1 for all the training samples. What are the training samples? These are the training samples again, which is, so we have to apply the new weight values on all the 4 training samples. So these are the 4 training samples. This is the first training sample with x1, x2 equal to 0, 0. Then second training sample, x1, x2 as 0, 1. Third training sample, x1 as 1 and x2 as 0. And the fourth training sample, x1 as 1 and x2 as 1. So we will apply the new weights on these training samples. It is shown here. So the new weights are these are the new weights, which is minus 0.5 and 1. So these new weights are to be applied. So xi wi will be calculated with w1, x1 w1 will be calculated with this, and x2 w2 will be calculated with this. Okay, so we get x1 as this, x2 as this, and target equal to 0. So when we calculate, what do we get? Minus 0.5 into 0 plus 1 into 0. So anything multiplied by 0 is 0. So we get the answer as 0. Target is 0, actual is 0 as output, so no change in weight. Second case, we multiply minus 0.5 into 0 plus 1 into 1. So this is minus 0.5 into 0 will become 0 plus 1. So this becomes 1. Then target was 1 and actual is 1. So no change. Now we look at the next example. In the next example, we see x1 is 1, x2 is 0. So minus 0.5 into 1 becomes minus 0.5, and 1 into 0 becomes 1 into 0 becomes 0. So our final answer comes out to be minus 0.5, which is less than threshold. Since this value is less than threshold, which is 1, which is theta, the answer is 0. Target is 0 and this is also 0. So when both are 0, there is no change required. After that, we have x1 as 1 and x2 as 1. So minus 0.5 into 1 plus 1 into 1. So we get 1 minus 0.5, which is greater than which is less than theta, which is less than 1. So the answer is 0 again. So target is 0, actual output is 0. Since all the outputs are same, no change required in the weights. So these are acceptable weights for Z2. Now what we have to do, now we have already done the setting of weight for Z1, then setting of weight for Z2. Now we have to perform Z1 plus Z2. All right, so let's go further. So why is Z1 plus Z2? We have to apply Perceptron rule for this. So we already have the value of x1, x2, and we have the values of Z1 and Z2. Okay, so we create one new table where we get the value of x1, x2, the intermediate values that we calculated for Z1 and Z2. Now we have to find out y, which is the sum of these two. So which type of sum? OR. So 0 plus 0 would be 0, 0 plus 1 would be 1, 1 plus 0 would be 1, and 0 plus 0 would be 0. So output y we get, if any of the input is 1, the output will be 1, else the output will be 0. Okay. Now we have these as the inputs. These two are the inputs and this is the output. So we have to use these values for input and output calculation based on new weights for Z1 and Z2. So the weights for Z1 and Z2 we are taking as 1. And these weights we are calling V1 and V2. These new weights for Z1 and Z2 are called V1 and V2, so that there is no confusion between W's and V's. Alright. So now again we will apply this. So those who do not know how to apply Perceptron on OR gate, this is the solution. Okay. So we have to apply sigma Vi xi, which was sigma Wi xi. Now since it is not W, it is V, we will say applying sigma Vi xi on all the 4 training samples, and Vi values are these. These are the values of Vi, which is 1, and these are the values of input, which is Z1 and Z2. So we will multiply all by 1 and we will add. So this into 1, this into 1, this into 1, and this into 1, plus 0 into 1, plus 1 into 1, plus 0 into 1, plus 0 into 1. So this is how we'll get the sigma. So what is the value of sigma for the first case? 0 into 1 plus 0 into 1. 0 into anything is 0, so it is same. So this is actual as well as target. Now we get 0 into 1 plus 1 into 1. We get 1. So this is 1, which is actual also and target also. Now we get 1 into 1 plus 0 into 1. So we get 1 as the answer. So it is same as the actual. Then 0 into 1 plus 0 into 1. So 0 into 1 means 0 plus 0 into 1 means 0. So actual and target are same. Since the target output and the actual output are same for all the 4 training examples, we can conclude that the weights that we have assumed to be V1 and V2 are fine and we don't have to update them. So this is what we get as the final output. So we have the value of x1, the weight for x1 is 1, which is W11, and the weight for x1 bar is minus 0.5. Okay, and then we have x2, the weight for x2 for z1 is minus 0.5 and the weight of x2 for z2 is 1. All right, and then the values of the weight for z1 and z2 is 1 again. All right, hence we get all the weights and inputs and outputs accordingly. So x1, x2 remains the same, the values of x1 and x2 remains the same. The values of z1 and z2 we calculated, and then we calculated the value of y and we compared them. And so the new and final values of our weights are W11 is 1, W21 is minus 0.5, W12 is minus 0.5 and W22 is 1. V1 is 1 and V2 is 1. Threshold is 1. Learning rate is 1.5. So this is what we have taken. If you want, you can take different values of learning rate also, then your output would be different. So I hope you have understood it. Kindly like and subscribe the channel and share it with your friends if you have understood the concept. So I am just briefing up all of it again in one go, that we are given a perceptron training rule and we have to adjust the weights if the actual output and the target output do not match. So this was the table which was given for XOR, and these are the inputs A and B, and this is the output, and we have to apply perceptron training rule for all of these, for which we assume the weights and everything. But before that, this we divide this as Z1 and Z2. So first we will find out Z1 and we will apply the weights for Z1, assume the weights for Z1. So for Z1 we have weight 11 and weight 21. For Z2 we have weight 21 and weight 22. Sorry, weight 12 and 22. All right, so what we are supposed to do, we are firstly supposed to find out Z1 4 cases training examples and then Z2 training examples, and we have to see whether the weights that we have assumed are fine or not. If they are not fine, we have to adjust the weight with this formula. What is the formula? I'm just writing it down for you. New weight is equal to Wi is equal to old Wi plus delta W. So this is the new weight, this is the old weight, and plus delta W. Delta W is the difference between the error of the weight. So we get Wi plus we get N, which is the learning rate, into target value minus actual output multiplied by Xi, which is the input. We apply this and we find out the new values of weight. Once we find out the new values of weight, these are to be applied to all the 4 training examples from the beginning. So we'll apply new values to all these 4 training samples, and then we will see whether the output which is coming is matching to the actual output or not, whether the target output is same as actual output or not, and we will repeat this process for Z2. Then we will apply this same process for Z1 plus Z2. I hope you have understood. Kindly go through the video again in case you have any doubt. So I have given this as step by step here. You can see this is step 1, that we are assuming x1 and x2 as A and B. Y equal to x1 into x2 bar plus x1 bar into x2. And then we apply the perceptron on these three functions, function 1, function 2 and function 3. Alright. So this function 1, function 2 and function 3 is here, and we apply it one by one on these functions. So you can see this is the step 3 where we are given the 4 training samples. We work on these values of W11, W21, threshold as 1 and learning rate as 1.5, and this is the diagram we'll get for Z1 in this case. We'll apply sigma xi wi for all the training samples which are related to Z1, and in case they are not same as the target, we have to update the weights. So for first case the values match, for the second case the values do not match, and then we have to apply this function for the second case. After getting the new values, we have to apply this entire set again on all the training samples, and then we will apply the perceptron rule for Z2, and after applying it for Z2 we will see if the target and actual output differ. We have to calculate the new weights. The new weights are calculated this way, applying the same formula. Then we have to apply these new weights to all the training samples again. So if they match, no update is required for the weight. Then we finally apply this for Z1 plus Z2. Again we have to calculate Z1 here, and we have to calculate Z2 here, and then we have to find out the OR relationship OR, and for that we are using the weights V1 and V2 for Z1 and Z2. We find out their multiplication according to their weights, and we see the output, and if it is same as the target output, then our purpose is solved and we can stop with the assumptions that we took. So this will be the final output for the XOR gate. Thank you so much.